All right, guys, next day and a half I'll be out of class. So we need to take a look at solving systems of equations with three variables. Just read the text from our note page here. Systems of equations can be solved no matter how many variables there are. The rule of thumb is that for every variable, we must have one equation. Once we exceed two variables, however, graphing is no longer an option for solving since we don't have more than two axes. Substitution works well when we can easily remove one of the equations. So right here we have solved the following system using substitution. Now as we go through this, you guys can pause as necessary because I'm going to go quickly because obviously there's no time for me to, I don't need to stop while I'm recording this. So third period, let's put Jaden in charge of pausing as necessary, and sixth period we'll throw Raymond Alfaro in charge of pausing as necessary. All right, so let's go ahead and we're going to do this by substitution. This is going to flow very similar. Actually, I don't need the whole thing. Let's just get. It's going to flow very similar to other problems we've done. Now, these do take up some room, so be aware of that. So if we look at this, one of them is already solved for a variable. Sometimes you're going to have to solve for one. This one's already solved for a variable. So this bottom equation, z equals x plus 5, is already solved for z. So I'm going to take what z is, and I'm going to substitute it in for z on the other two equations. So now my top equation says negative 5x minus 3y plus x plus 5 equals negative 4. And my second equation is negative 2x minus 2y plus 2 times x plus 5 equals 4. This plus, if I distribute it, does absolutely nothing. Just so I can get it step by step, I'm still going to show that I can just remove the parentheses. This 2 on this one is going to distribute. And I'm here. So I've still got two separate equations. I kind of work on them simultaneously. That's my preference. If you guys want to work on them one at a time, you can. I'm going to combine like terms. Negative 5x and positive 1x make negative 4x minus 3y plus 5 equals negative 4. I'm going to move that, all the numbers onto the other side. So that's going to be equals negative 1 as I move that 5 over. Here it's kind of nice. I picked an easier problem. My 2x's cancel. That won't always happen. And I'm going to move my negative 10, or sorry, move my 10 over. So now I have negative 2y equals 4 minus 10 is negative 6. Divide both sides by negative 2, and I have y equals 3. I like that. So now that y equals 3, I can go ahead and substitute it in for here, and I have negative 4x minus 3 times 3 equals negative 1. That's negative 4x minus 9 equals negative 1. Add 9 to both sides. Those cancel. Negative 4x equals 8. Divide by negative 4. And x equals negative 2. So now I've got three variables to solve for, but I've only gotten two so far. I've got x and y. So I need to find z still, so I can take that x value and substitute back in. I call this daisy chaining because they just kind of daisy chain back into the previous problem. So now I have z is equal to negative 2 plus 5, so z is equal to 3. So my final solution, the way I should write it as a 3-variable coordinate in x, y, z alphabetical order. Actually, I'm going to write that. It's an x, y, z coordinate, so my solution is negative 2, 3, 3. And that's solving by substitution. However, it's not always this easy. And if we don't have an easy equation like this third one here, we're going to want to use elimination. You guys should remember elimination from our 2-variable version. Oh, actually, so right now, I want you guys to Take some time if you need additional time. Try to do numbers 1 and 2 in your workbook. Let's set aside 10, 15 minutes to do that. I'll give you solutions to the workbook problems tomorrow for class. So right now, pause the video for maybe 10 minutes. Try out numbers 1 and 2. See if you guys can get there. After 10 minutes, let's finish the note up and get the substitution method, the elimination method in. Elimination needs more room. Just to warn you guys. So the goal is always to try to eliminate, hence the word elimination, eliminate a variable. We want to get down to one variable to solve for. So here we have 3 equations. We have negative 6x minus 2y minus z equals negative 17. We have 5x plus y minus 6z equals 19. Negative 4x minus 6y minus 6z equals negative 20. So we can add our equations, but remember but that won't necessarily eliminate a variable. So here's the thought, the big thought here. What we do to one side, we do to the other on all 3 of these equations. What we do to one side, we do to the other. As long as we hold to that rule, we can change these equations. That's in quotation marks because we're technically not changing them. We can change these equations to whatever we'd like to make sure that if we stack them and add them, a variable gets eliminated. So when I look at these 3 equations, I notice, I don't want to multiply by big numbers, I notice that the y values are all kind of small. 6 is our biggest one. 2 and 1 are our coefficients on our other y's. I can get those to match. So let's get them to match. So I've selected, it's your choice. You're free to select whichever variable you feel will be easiest to get rid of. For this first one, I'm going to pick for you, and I'm going to say y is going to be the easiest thing for me to get rid of. I'm going to label these 3 equations. This is equation 1, equation 2, and equation 3. So the first thing with elimination is you pick a variable to get rid of. I chose y. Then you pick 2 equations. So I'm going to pick equation 1 and 2. My y's don't match. How could I make my y's match? That's the question. I can multiply my second equation by 2. Remember, if you need to rewind so you can hear me again, do so. I can multiply my second equation by 2 to make my y's match. So I'm going to do 2 times equation 2, and then I'm going to add it to equation 1. So 2 times equation 2 is 2 times 5x plus y minus 6z equals 19. What I do to one side, I do to the other. And then equation 1 is negative 6x minus 2y minus z equals negative 17. I didn't multiply that one by anything because I want to keep it a 2. Now I'm going to pick 2 different equations. I'm going to still pick equation 2, and I'm going to try to use it to eliminate y in equation 3. My equation 2 has 1y, my equation 3 has 6y, so I'm going to do 6 times equation 2, and I'm going to add equation 3. I'll go over the reasoning behind this again in a second. I'm going to just need a little bit more room here. And I like working, once again, I like working side by side. So 6 times equation 2. Six times equation 2, and then I'm going to add equation 3. So negative 4x minus 6y minus 6z equals negative 20. So in both of these equations, I'm going to end up eliminating y, and we're going to see how in a second. So I'm going to working on the left-hand one, I'm going to distribute my 2, and I get 10x plus 2y minus 12z equals 38. Then I rewrite my equation 1. All right, over here on this one, I'm going to distribute my 6. So I get 30x plus 6y minus 36z equals 114. Right? Let's see, that's 120 minus 6. Yeah, 114. So now, since my y's are opposite signs with the same coefficient, so what I'm referring to, I'm going to erase this circle in a second. That's a positive 2 and a negative 2. This is a positive 6 and a negative 6. Those are going to cancel now when I add them. So 10x minus 6x is 4x. The y's are gone. Negative 12z minus z is negative 13z. And 38 minus 17 is 21. Notice y is now gone. I have an easier equation. 30x, I'm going to the right side now. 30x minus 4x is 26x. 6y and negative 6y cancel. Negative 36z minus 6z is negative 42z. And 114 minus 20 is going to be 94. So now I have these two equations. They both only have x and z. They both only have x and z. So now I'm going to use elimination again. Now, taking a look at them, they're not pretty. 4, 13, and 20 and 1, there's nothing I can divide by. 26, 42, and 94, though, I can. Is it really, will it help me to do so, though, is a question. No. So I picked a poor variable with y, but I've already committed myself this far. I need to make something match again, right? So I'm going to pick something to get rid of, and unfortunately, I'm just going to have to multiply both by this. If you need a calculator, use a calculator at this point because the numbers are going to get big. So let's go ahead and pick my x's to match. So now I'm going to stack them just so we can see. I want to eliminate again, and I need to pick a variable again to eliminate. I'm going to eliminate x only because of the fact that 4 is a smaller number. 4 is a smaller number. Now I'm actually, you know what, I am going to go ahead and just divide both of these sides by 2. Just so I get easier numbers. You'll get a lot of rewriting when it comes to the elimination method, which is why I gave you almost an entire page to do it. So this is going to be 13x minus 21z equals 47. So I want to get rid of x. Unfortunately, they don't match, and also unfortunately, there's not some easy number I can multiply 4 by to get 13. Or 13 by to get 4. I also want them to be opposite signs. So when this happens, since they're both relatively prime to one another, I'm going to multiply the top one by 13. I'm going to multiply the bottom one by negative 4 because I want them to be opposite signs. Since they're already the same sign, I need to multiply by a negative. That's going to change our equation one more time. We're getting nearish the end. 13 times 4, okay, we could do that one. That's 52x minus 169z equals, what we have 273. So that one didn't need a calculator yet. Then we have negative 52x, which is what I wanted because I want to cancel those, plus 84z equals 188. Negative 188, I apologize. Negative 188. Well, I guess we didn't need a calculator yet. Well, I didn't, but if you guys needed one, I understand. So now our x is canceled. That's what we wanted. 169, negative 169 and 84 are going to make a negative 85. And 273 minus 188, we're going to get 85. divide both sides by negative 85, and all that mess just to get a very simple z equals negative 1. Now the daisy chain kicks in. We're going to plug this z in. I'm going to shrinkify this a little bit so we can see our whole problem-ish. Yeah, I can fit it. Okay. So daisy chain it, z equals negative 1. That's going to plug into either one of the two equations that only have x and z. So that's going to go up here. So now I have 4 times x minus 13 times negative 1 equals 21. That's 4x plus 13 equals 21. Subtract 13 from both sides. And we have 4x equals 8, which means x equals 2 if I divide both sides by 4. Now that I have z equals negative 1 and x equals 2, I'm going to have to go back to one of my original equations, any one of them. I'm going to plug that in for z, and I'm going to plug that in for x. So now I've got negative 4 times 2 minus 6y minus 6 times negative 1 equals negative 20. Sorry about the arrows cutting in through that. Now I have negative 8 minus 6y plus 6 equals negative 20. Combine like terms. Negative 6y minus 2 equals negative 20. Add 2, negative 6y equals negative 18. Divide by negative 6. And I get y equals 3. So I found my x, I found my y, I found my z. So my solution is 2, 3, negative 1. So between the notes today and your workbook problems, because now I'm going to want you to try workbook problems 3 and 4, between today and the minimum day tomorrow, Friday, we're going to do that. Monday, we're going to look at a third way of doing this, and we'll see how well you guys like that way. All right. Have a good day. Behave for Mrs. Bates.